I have a problem. My NAS, or Network Attached Storage, where I put all my old projects and back up all my computers, is this 2011 Mac Mini. It made a valiant effort, but it only has USB 2.0, so when I copy over a 20 gigabyte video project, it copies at a leisurely 35 megabytes per second. It's been 10 years for this thing. This Mac lived a good life, but it's time to move on. But to what? Well, the answer came in the form of an email. After seeing my video on the Raspberry Pi SATA NAS I set up late last year, a representative from ASUSTOR emailed me and said, "Hey Jeff, I like what you're doing with the Pi. How about we send you one of our NASs and you can compare it to the best Pi NAS you can build?" I asked more about it and he clarified, no sponsorship dollars, no strings attached. We just want you to try out our NAS and see what you think compared to a Pi NAS. So I took him up on the offer and he sent me this. This is the ASUSTOR Lockerstor for AS6604T, and it has a lot of features. It has a quad-core processor, Intel-based. It has 3 USB 3.2 ports, 2 M2 slots for caching and speed up, or you can use them for extra storage. It has a dual 2.5 gig Ethernet jack, and it has a 3-year warranty, which is always nice when you're paying for something. And it even has an HDMI out port, so you can use it as like a media player. And if you look at the spec sheet, there's tons more details. There's a lot of different things that this thing can do. It has a lot of features. I'm not going to get into everything because this is not a review of this ASUSTOR device. This is talking about how this compares to a Raspberry Pi based NAS setup. So let's get the thing open. And it comes with an accessory box here. And I don't need that giant box or that. Here's the actual unit. So one of the nice advantages of getting an out-of-the-box NAS like this is the fact that everything is self-contained. It has 4 drive bays and it includes a screen on it and some buttons for managing the NAS. And it has an on-off button up here and some status lights. All the hard drives have LEDs. Just a lot of nice features. And going around to the back side, it just has the ports that we need. So those 2 2.5 gig Ethernet jacks, 2 USB 3.2 ports, an HDMI 2.0A out port, a giant fan to keep everything cool, and this NAS has a really cool feature that I won't be able to replicate on the Pi, at least not the Pi that I'm going to be setting up today. You can use 1 or 2 NVMe drives like these two guys and use them for caching read data and caching write data. That's going to make your NAS be a lot faster. So I'm actually going to install these two really quick here. All right, the external case pops off. Another thing that this board has that the Raspberry Pi does not is expandable RAM. You can actually put 8 gigs of RAM inside to speed up I/O operations, which is nice. I'm not going to do that upgrade today, but it's something that I could do if I wanted to. This is the part that I'm interested in. There's a riser card here. It's a PCI Express. I think it's a 4x slot right here. And it goes into a riser with 2 M.2 slots, one on the front and one on the back. So if I take this off, I can put my M2 cards in and add to the performance of the whole NAS by letting it cache reads and writes. So you can see, I might even be able to get this working on the Pi if I wanted to, but I would need a PCI switch to be able to get both of them working. So I'll install these 2 drives. And this is a WD Black SN750. I got this on sale on Amazon, so I'm going to stick it in and see how it performs. It's 500 gigs. And then this is an XPG SX6000 Lite 128 gig NVMe drive. This is a little smaller, so I'm not even sure if this will use one for the read and one for the write, or if it uses both for both, or how that works. But if you only have one installed, it'll only let you do read caching. But if you have both, it'll do read and write. Okay, so I have both of the 2 NVMe drives installed, one on either side of this board, and I can put it back into the device in that slot. And you can see it's a by 4 slot, And this is the main board of the device. It has a battery for real-time clock. It doesn't have hardware RAID or anything like that on it, but it is a worthy little computer in its own regard, a little bit faster than the Raspberry Pi, but it's not going to win any speed records compared to something like a full desktop PC. And while we're inside the case, you can take a quick look. It does have a nice large cooling fan, which I always like. That means it's going to be a little bit cooler, or a little bit quieter than having a bunch of small fans. All the case is constructed out of metal parts, which is nice just for stability. One downside is that also creates a little bit more noise in terms of the echoes and amplification inside the case. But it should work out all right. It looks like a pretty well constructed case. It feels pretty solid. So let's get that cover back on. All right, so we got our 2 caching drives installed. And next up is one of my favorite parts of any new device. We're going to remove these plastic little protective covers. Some people never do this. I don't understand those people. It's one of the most satisfying parts of buying a new piece of equipment. And if you buy used, you never really get to do this. Some people leave this on until they get all bubbly and nasty, but I like to take them off. Very nice. And that is as clean as that will ever be. All right, so the next step is we're going to put some drives into this thing. And I actually talked to the person who sent me this ASUSTOR NAS, and thanks again so much to ASUSTOR for sending this to me. They got me in touch with somebody from Seagate who decided that they would also just send me, with no strings attached and no sponsorship dollars or anything, but they did send me these drives, which I'm counting as sponsorship. That's why there's a little badge on this video. Seagate sent me their IronWolf NAS 8 terabyte drives, and they sent me 4 of them. So depending on the RAID type that we make, we could have a 16 terabyte RAID 10 array, or we could have a 24 terabyte RAID 5 or RAID 6. But these drives are made for NAS devices specifically, and one of the nice things that Seagate has done in the past few years is make it very clear which of their drives use CMR versus SMR. And I'm not going to get into the details on this, but CMR is conventional magnetic recording and SMR is shielded magnetic recording. And the two differ in the way that the read and write heads put data onto the drive. And there was a big to-do in the hard drive industry last year, because I think it was Western Digital was selling some NAS-rated hard drives to consumers that had SMR, and it's not good for a lot of write activity. It makes things a lot slower. The hard drive has to do more garbage collection. So that was a big issue last year, and so Seagate makes it very clear that these are CMR. They're going to be good performing drives for a NAS. And everybody in the world has their own anecdotes about which hard drives are the best, which ones fail all the time. I know a lot of people have mentioned that these are like 5 or 10-year-old green power drives by Western Digital. These things will probably blow up in my face, and that's probably true. But I bought them because they were $20 a pop versus these guys, which are $200 a pop. I was using those for testing. I'm using these for actually testing out the performance of a good NAS like this. But no matter what, you should try to get hard drives that are suitable for the use case that you have. If you're an enterprise storage person that's trying to get tons of terabytes of high speed, high capacity, always online data, you're probably going to want to use SAS and maybe SAS NVMe drives, like I talked about a couple videos ago. But if you're building a home or small business NAS or something like this, NAS drives like this are great for that because they're built for the moderate use case. They're not going to be going 24/7, 100%, but they might be going a lot, and you want a good hard drive like this. So thanks again to Seagate for sending me these drives. These are the 8 terabytes. I believe that their entire line of the IronWolf NAS, the 4, 2, 4, 8, and 10, I think they might have 12, 16. They have a lot of different capacities now. All right, so I'm going to open up these drives and put them into the cages. And that is a lot of hard drive there. This is, let's see, $800 just worth of hard drives. And I know that that's a little much. The nice thing about a NAS that has multiple bays like this, or even with the Raspberry Pi, is depending on the type of RAID you set up, you can actually add or remove hard drives over time. And that way you don't have to spend 800 bucks right out of the gate if you want this much capacity and this much performance. You could start out with 2, 4, 6, or 8 terabytes and expand from there. So these drive trays, let's see here. You push the button and it slides out. These drive trays are kind of a blend. There's a plastic jacket on the outside that blends to a metal tray, which is nice because the metal tray is going to be rigid and hold things together well, and do a good job just making sure that the drive is secure inside of the all metal case. So I'm going to put these in, and there should be, I hope, some screws. There are screws in here in the quick installation kit. These are for 2.5 inch hard drives, and these are the ones for the 3.5 inch hard drives, like these guys. These drive trays do let you put in 2.5 inch drives, like most SSDs, but we're going to be putting in these 3.5 inch drives. So now I got them all in their trays, and I'm going to slide them into their slots in here. And that's upside down. So let's do it the right side. There we go. There's one. 2. 3. And 4. Now, it got considerably heavier at this point because now there's 4 massive hard drives with a lot of drive platters in there. Luckily, this desk, which was the cheapest one I could find on Amazon, is still holding up. Let's power it on and see what happens. This power supply that comes with it looks like it's, what is the output? It's a 12 volt, 7.5 amp / 90 watt power adapter, so that's going to give it a lot of juice if it needs it. I also have my kilowatt here, and I'm going to use it to measure how much power this NAS actually takes while it's running, and I'm going to compare that to the Pi with its hard drives connected as well. So I'm going to plug that in. Before I plug it in, I also want to make sure that I plug in the network, and this has 2.5 gig networking. I'm going to do a whole video talking about 10 gig networking and 2.5 gig networking soon. I have a 1 gig network for my whole house, so I'm going to connect this to that for now, but I'm going to do some performance testing connected directly through my 10 gig network to my Mac and see how it performs. The NAS comes with a couple cables. I believe that these are just Cat 5e. Let's see. Yeah, Cat 5e cables. These are rated up to 2.5, maybe they could probably even do 5 gig networking. They might even be able to saturate a 10 gig network over a short distance. I have a little drop and a network switch over in the corner here. And I'll plug it into the back here. And then I'll plug in power. There goes the power adapter. And I'll plug in power after I turn this thing back around. Oh, it got a lot heavier with those hard drives. Now it has power. And one of the other nice things about this enclosure, I already can see it compared to the Pi that I'm going to build, is that everything is self-contained. It's all nicely packaged. I don't have to 3D print any custom cases that hold things together. And it has one button here that's going to turn it on. Another thing I just noticed is that these 2 drives spun up first, and now it's spinning up these 2 drives. So it does that to prevent a huge power surge when all the different motors on the 4 hard drives start spinning up at the same time. So this is doing its boot up process. It'll probably take a couple minutes, and at the end of it, it should beep. And I believe that this will tell me the IP address of the system, which I would pay 10 or 20 bucks just for that feature on any NAS, just to have a little screen that shows its IP address so I can find it on the web UI immediately. With the ASUSTOR, you buy it, open the box, install some drives, and turn it on. Building a Raspberry Pi NAS, though, can be a little overwhelming. If you just want a NAS, you might be better off buying a NAS. But if you want to experience building a NAS, making lots of little decisions and customizing the setup to your exact needs,
then you might be better off building a NAS with a Raspberry Pi, or even a full-fledged mini ITX PC if you want to get the best performance and still have a small package. There's a third group of people though who don't need a NAS at all, they just want to watch me suffer through some painful experiences building my own. And that's okay too. When you build a NAS with a Raspberry Pi, you run into some problems right out of the gate. How are you going to connect drives to the Pi, and how do you power them? Will you use software like Open Media Vault to manage your NAS, or configure everything from scratch? For networking, will you rely on the Pi's built-in gigabit Ethernet, or try to upgrade to a faster 2.5 gigabit connection? There's an immediate level of complexity ASUSTOR already solved by building the whole box for you. And you pay a small premium for it, but that premium is worth it if you aren't in it for the experience or extreme customization. Anyways, I decided I'd try setting up my Pi NAS using a Compute Module 4 I/O board with a PCI Express switch that connects to a 5-port SATA card and a 1-port 2.5 gigabit Ethernet card. Check the description for specific parts and links, along with a blog post detailing the hardware setup. I'll talk prices soon, but for now, know that this setup was about $350 all in, compared to $550 for the ASUSTOR. On paper, this setup has some specs similar to the ASUSTOR NAS. They both have a quad-core CPU and 4 gigabytes of RAM. They both have 2.5 gigabits Ethernet, and they both have 4 SATA hard drives. But the devil's in the details, which we'll talk about later. And I could use a dual 2.5 gig network card on the Pi for link aggregation, but I already know the Pi is bandwidth constrained from earlier videos, so I'm going to limit it to a single 2.5 gig interface. So now, how is it building a Pi NAS?
So this was nice and simple. You just put the 4 drives in, plug the thing into power, everything works great. Now let's look at what it takes to get a similar hardware setup, not the same hardware setup, but a similar hardware setup on the Raspberry Pi. And I'm going to use the Raspberry Pi Compute Module 4, which also has a quad-core processor, and it has USB, but it's USB 2 built in. You'd have to add your own USB 3 card. It has gigabit Ethernet built in, so we're going to have to add in a 2.5 gigabit Ethernet card through this PCI Express slot. And there's a few things that we'll have to be concerned about though. One is that the power connector on here can power maybe 1 or 2 cards through here if we use a suitable power supply, but it's not going to power the hard drives themselves, so we have to power them separately. And these hard drives, these IronWolf NAS drives, use 0.85 amps per drive. So to be safe, we'd want a power supply that has at least 5 amp supply on the 5-volt bus for these 4 drives. Otherwise, they're not going to spin up properly and they're not going to work well. These older green power hard drives that I used in some of my other testing only needed 0.65 amps, so I could run them off of a 2 amp supply okay-ishly. I wouldn't recommend doing that, but that's what I did. So do as I say, not as I do. You're also going to need to mount the hard drives. So there are external enclosures for multiple hard drives that have SATA connectors and things. A lot of those are pretty expensive, so I chose this, which is a lot cheaper, and we'll do a cost comparison at the end of this thing. But these cages kind of slide into each other. You can put on as many or as few as you want, and you could integrate them into some other form of case. But so the first thing that I'll do is pop all these drives into the cages so that we can have them at least not hanging out here ready to fall over. All right, so the hard drives are all wired up. Well, they're not wired up, but they're wired in. The next thing that I'm going to need to do is have a SATA controller so that the Raspberry Pi can talk to the hard drives. And this one uses a Marvel chipset on it, and it has actually 5 SATA ports. So I could put on 5 drives, but I'm just going to be doing the 4 today. One thing that you might notice is that the slot right here, the pinout for it is by 4, and this is a by 1 slot. So I'm not going to be able to plug it directly in there. So I'm going to need to use an adapter like this one, which lets me plug this card into this slot. But we have another problem here. I wanted to get 2.5 gig Ethernet, and this onboard Ethernet, which uses the chip on the Pi up here, is only 1 gigabit. So I want to use this card, which is a 2.5 gigabit Ethernet card, and it actually does fit nicely in that slot, but it's not going to work with both cards at the same time because we don't have any way of plugging 2 cards in. So I'm also going to need a PCI switch. And this is a PCI switch using a Texas Instruments switch chip on it, and it has 2 slots and it has an external power connector to power the boards that are plugged into it. So I'm going to try this out. I haven't tested this before, but hopefully it'll work, and hopefully that will let us get both 4 SATA drives connected and 2.5 gig Ethernet. So we'll plug all this in together and we'll see what happens. You can already see that it's a little bit less of a clean slate than that NAS. And if I really want to build this to be production ready, I'm going to have to build a custom case for all this and probably use a different adapter than this one so that I can have different things set up in it. But now that we have those things plugged in, I'm going to start plugging in the hard drives themselves. So I got these plugged in, and then I'm going to plug them into the controller card. Right. Then I'm going to need to power this PCI switch, so I actually have a power supply for it, and I'll have to just leave this hanging off for now, which is a bit janky, but that's the way it's going to be. I also need to keep everything nice and cool, so I have this Noctua fan and a PWM or pulse width modulation controller that lets me control the fan speed on it. So I'm going to set this over here and plug it into the Raspberry Pi's fan connector. So I got that set up, this set up. I'm going to need to power all the hard drives, so I also need to plug them into a power source, which I'll do like this. All right. And at this point, I'm going to need to power these, and I'm going to use a PC power supply for that, just because that's going to provide me enough power to power up all 4 of these high-powered hard drives separately from the Raspberry Pi itself. So I have this PC power supply, and one annoyance with a lot of these PC power supplies, this one is fully modular, is you have to have a way to turn on the power supply. It has an on-off switch on the back, but that switch doesn't actually put power to the outputs. You have to short the PS on to ground, which this connector does, and that'll turn on the power supply and give it output through all these different modular plugs, which I can then use to power the hard drives. So I'm going to plug everything in here and see how that works out. And I should note that this power supply says that it's 5-volt rail supplies 100 watts, and the 12-volt rail supplies 696 watts and 15 amps. So it should be enough to power these hard drives. We'll see if that's true or not in just a moment. All right, so the hard drives all seem to power up okay through this power supply. One thing to note is that I could use this power supply to power the Pi and to power this external card as well, but just to keep things a little bit safer, since one time I accidentally shorted something in here and caused some problems. So I have this wired up through a separate Molex power supply, and I'm going to power the Pi through a 5 amp 12-volt power supply using this barrel plug. So I'm going to turn on the PCI switch using that. So now these cards should have power. And I'm going to turn on the Raspberry Pi itself after I plug in the network interface. So this is just going to do 1 gigabit networking for now, and then I'll switch to 2.5 gigabits when I want to do my performance testing after I get the software sorted out. So let's see what happens. All right, so everything turned on. I'm actually going to switch the network jack to the 2.5 gig card and see if it's actually working to get a link. Looks like it is. So this is all good signs. What I'm going to do now is go over to the computer and see if we can see all the drives, see if we can get them set up, and we'll go from there. And for that, I hate to do this to you, but I'm gonna have to make you wait until part 2, which is coming next week.
I'll compare the rest of the setup for both NASs, I'll benchmark them, and I'll share some interesting problems I ran into on both devices. I'll give my final verdict then, so subscribe to see it. And until you watch that video, I'm Jeff Geerling. Bandwidth constrained, so I'm gonna limit it, I'm gonna.
5 gigabit Ethernet card through this PCI-X, it's not PCI-X. I'm gonna need to get my pliers really quick, hold on.
A lot of people want to watch me suffer. I mean, it's just good entertainment.